Ladies and gentlemen, it's time for another fun-filled evening of chemistry. So try and calm down your excitement and let's talk about matter and why it matters. Alright, first thing we need to do is talk about the basic building blocks of life and even not life, inanimate objects. Everything is made out of elements. These are the basic building blocks of everything. It's the smallest unit of something that still has the properties of that something. So for example, this right here is carbon. And carbon on your periodic table is element number 6, and its symbol is C. And so these pieces of carbon, this is coal, so you've seen carbon before. Your pencil lead is made out of carbon. A single one of these chunks, like that chunk right there, is not a single atom of carbon. Instead, it's billions upon trillions of atoms of carbon stuck together. So if we were to take a single one of these chunks of carbon and we were to cut it in half, it would still be carbon. It would still behave the same as carbon. Both of those halves would still have the exact same properties. They have the same density, same melting point, same chemical reactions that they go under. And if we were to take one of those halves and cut it in half again, same thing. It would still be carbon because they'd be the exact same element. But eventually, you're going to keep cutting in half and in half and in half, and you're going to get to a point where you hit a basic building block of that carbon, so a single unit of carbon, and that single unit would be the atom. And so it would look something like this guy right here. So a single atom of carbon would be the last or the smallest unit that still has the properties of carbon. So an atom then is the smallest unit of an element. So if we were to break apart one of these chunks of carbon into a single atom, that atom would still behave just like one of these big chunks, but it would be the smallest. If you were to try and break that atom up even farther, so let's say we were to take an atom of carbon and split it up into protons, neutrons, and electrons. Okay, the positive, neutral, negative charges of an atom. This proton wouldn't have the same properties of carbon. Even though it might have come from the carbon, it's going to behave differently. So once we break it down even farther, this guy right here, it's not going to behave like the whole element. So the smallest chunk or smallest piece of an element would be an atom. You can throw multiple atoms of the same element together and still maintain those same properties. So billions upon trillions of atoms versus a single atom are going to have the same behaviors. And here it is, the grand all-inclusive list of every single element known to mankind. Some of these are natural, found out in the living world. Other ones are synthetically prepared inside of a laboratory. But these are the building blocks of everything. So everything starts as one of these. A single atom of boron, a single atom of carbon, nitrogen, oxygen, fluorine are all going to have different properties. They're all 4 or 5 going to be made of protons, neutrons, and electrons. Every single element on this list is made of protons, neutrons, and electrons. But depending upon the combination, you're going to have different properties. And you can have huge chunks of these, you can have very small amounts of these. And then from this selection of elements, we can build basically everything in the world. You just have to bond them, mix them, whatever you need to do to make what you're trying to make. That brings us then to compounds. So right here we see a very large compound. This is actually sugar, so those two represent the exact same things. This would be a single molecule of sugar. So just like an atom is the smallest unit of an element, a molecule is the smallest unit of a compound. So if we were to break this in half, let's say we were to snap that little bond right there, it would no longer be sugar. It would behave completely differently. So the smallest that you can bring down a compound would be a single molecule. Whereas one of these grains of sugar right here, it's not going to be a single molecule. It's going to be billions upon trillions of molecules kind of stuck together in one crystal shape. And we could break it apart into single molecules then. So a molecule really is composed of 2 different things. You have elements, and so each of these different colored orbs represents an element. And in this case, we have some carbons, some oxygens, and some hydrogens. So 3 completely different elements, and they are joined together by what is called bonds. And so each one of these little sticks right here represents a chemical bond that's holding it together. So we start off with the basic building blocks, okay, single atoms of a particular element. We bond them together chemically, and we wind up with this large thing that's called a compound, or a single molecule. Next, we talk about mixtures. So some mixtures are really easy to identify by looking at them, other ones not so simple. So like this rock right here, you can look at that rock and you can see some dark spots, you can see some light spots, you can see some kind of yellow spots. Those represent different things, and that shows us it's a mixture. Okay, so they're not bonded together, they're all just kind of squished together. There's going to be lots of elements, lots of different compounds in here. And that's what makes it a mixture then. So it's a mixture of different things. It could be a bunch of different elements, could be a bunch of different compounds, or just one or the other, all mixed together. The ones that are trickier to see is something like this. So this is a solution. It's a homogeneous mixture. We can't really tell the difference in between any of the parts. But if we were to zoom in and take a look at just a single subsection of that right there, we would see lots of different things. Okay, so, Kool-Aid, it's going to be made out of water. And water would be an example of a compound because it's composed of hydrogen and oxygen joined together by bonds. It's also going to have some sugar in there, which is C6H12O6, so 6 carbons, 12 hydrogens, and 6 oxygens. Once again, that's another compound. And then you would have some purple mixed in there too to give it color and purple flavoring. And since we have that selection of individual pieces that are all in here, that would make this a mixture as well. Even though when we look at it, it looks the same throughout, so we might think maybe it's just a compound or an element. It's not. There's several different things in there making it a mixture. And in this case, it would be a homogeneous mixture versus a heterogeneous mixture like the rock was. Okay, physical properties. So we're going to talk about properties that all matter has, so we can identify matter based upon its properties, and there's two kinds, physical and chemical. So a physical property is a characteristic that can be observed or measured without changing the identity of the substance. So for example, melting and boiling, both of those would be physical properties. Say you have a piece of ice and you melt it, it's still going to be water, even though you melted it. You're not changing the identity of the compound, of the substance. It was H2O when it was a solid, it's H2O when it's a liquid. Same thing with boiling point. So if you boil some water, it's still going to be H2O. And then the state of matter. So if it's solid, liquid, or gas, it's still the same thing. Okay. And then a physical change is kind of the same idea. You're changed to the substance that doesn't change its identity. So grinding, cutting, smashing. So let's say, for example, you have a sugar cube and you smash it with a hammer. When you smash it with a hammer, what you're going to turn it into is tiny little crystals. Okay, you're going to grind it down. It's still going to be sugar, though. Okay, if you were to lick the sugar cube or lick the granulated sugar, it's going to taste the same. It'll have the same properties. So you're not really changing its identity. So that's what's important about a physical property. It relies solely upon the identity of the compound or substance. Another important part of this is a physical property. Way to remember it can be changed back. So for example, if you melt an ice cube, you can refreeze the ice cube and put it back to where it was before. So you can change a physical property back to where it was before. Here's an example. So these are both sulfur. Sulfur has 16 protons, 16 electrons, and 16 neutrons. So a single atom of sulfur would look like this. It would have the properties of the bigger chunks. This would just be billions upon trillions of different sulfur atoms joined together. But both of these two would have the exact same properties. Here we have large chunks of sulfur, then we take it and we crush it down and it turns into a powder. But both of them are still the exact same thing with the same properties because they have the exact same atoms. Okay, nothing's changed there. That brings us then to chemical properties. So a chemical property is a substance's ability to undergo changes into a completely different substance. So this is different than a physical property where you're not actually changing the compound. This one you are changing it to something different with different properties, different physical properties and different chemical properties even. So like a piece of paper is flammable. If you were to light a piece of paper on fire, it's no longer going to be a piece of paper. So it's not a physical property because when you light it on fire, it turns to ash, smoke, gas, all kinds of different things that are not the same. You can't take that pile of ash and form it back into a piece of paper. You've changed it. Same thing with tarnishing. This is another word for rusting. You know, if you leave your bike outside in the rain and it starts to rust, it's no longer iron anymore. It's now iron oxide. It's a completely different substance with completely different properties. So we would say then that the chemical property of iron is that it will rust. Okay, that is a chemical property of iron. That's how we can identify iron. It's something that rusts. A chemical change then is when that substance actually does that chemical property. So if we put iron outside and we let it rust, it's undergoing a chemical change. It's changing to something completely different. It's not like smashing where it stays the same. It's changing to something brand new. So then just like a physical property can be changed back, a chemical property cannot be changed back. So like this egg right here, you put an egg on a frying pan and it's going to change the properties of the egg. It's going to turn hard. Eventually you can scramble it and all that kind of stuff. It's going to get brown around the edges. Those are all chemical changes and chemical properties of the egg. You know, you can't take a fried egg and then convert it back to a raw egg. That's impossible. That means it's a chemical change. So let's take a look at these two pictures. Both are bananas. Okay, so they're representing the exact same substance, but they've undergone some changes, obviously, from this to this right here. What changes have they undergone? Well, we can see that they turned to brown, okay, or black even, from the yellow color that they were before. That would be a chemical change, okay, because it's changed from yellow to black, and it's changed to something completely different with different properties even. It's going to be mushier, and it's going to have a different taste and feel and look and smell. But there's also a physical property here. Can you spot it? Yeah, if you look right here, they've been separated from each other at the stem, and also this one's been split open. That's a physical change that it's undergone. Okay, we've opened it up. We haven't chemically changed the skin by peeling it back. We've just physically changed it, so we changed the way it looks only. All right, I hope that helps. There's going to be a lot of identifying for this particular lesson. You've got to be able to identify elements, compounds, and mixtures, and also physical properties and physical changes, and chemical properties and chemical changes. So you've got some good notes now, and hopefully these will help you identify those in the future on your own.